Hi all, so I seem to have forgotten to plug my computer in, which is why there's now a second part to this video. Um, so let's see if we can continue where we left off. We were working on problem number 5, and 5 said we've got y equals square root of x and y equals x over 3. So I graph these. There's square root of x. There's x over 3. They intersect here. I could certainly set these equal to each other. Um, in order for this line to intersect here, I'd be expecting an integer value. If I put a 9 in here, 9 divided by 3 is 3. Square root of 9 is also 3. So this is going to be 9, 3. But I would certainly do it on my calculator to find that point of intersection by graphing each of those functions. Okay, so there's our region, and what are we talking about doing with that region? In part A, it says find the area, and so I know that I'm going just to do top minus bottom, square root of x, minus x over 3 dx, and I end up with 37.962 units squared here for my area of that region. Now, in part B, they ask us to rotate this region around the vertical line x equals -1. Well, you know me, given the opportunity, I'm going to prefer to write this as a shell. So for me, my radius is x, and my height is top minus bottom, or square root of x minus x over 3. And so my integral is 2 pi 0 to 9 and x times square root of x minus x over 3 dx. You can certainly do this problem, if you prefer, by saying I've got a washer with a hole in it. I've got a disk with a hole in it, and my little radius here is r. That is the x value for this curve, and this curve is y equals square root of x, which means x equals y squared. And my big radius here is this other x value, and that's equal to the x value here, which would be 3y. And so I could also set this up as pi 3y squared minus y squared squared dy. And remember, since this is a dy integral, we're integrating this way, so that's our upper boundary of integration, 0 to 3. We're not integrating this way, 0 to 9, we're integrating this way, 0 to 3. So either of these should generate the correct answer for me, and the answer I got was 599.618 pi, or 1871.190. Okay, and let's take a look at part C. This time we've got cross sections perpendicular to the y-axis are squares. Okay, so let's take a look at this region. Perpendicular to the y-axis are squares. So I'm looking at something like this, where the side length of my square is right minus left. Right minus left. So this is x that goes to that curve. See, they really liked you doing it with washers, because you've already found out what x was. Okay, so what do we know about this function? This is y equals square root of x, where x equals y squared. So this x is y squared, and that's my left, y squared. And the right, that's this distance, and that's the x value that goes to this curve, which was y equals x over 3, so x equals 3y. So here we're going to have 3y. So this is the side length of my square, and I'm looking to integrate area of the square, which means we're integrating side length squared dy. So we're going to go from 0 to 3 of 3y minus y squared dy. And don't forget that. This is the side length, but I need side length squared because I'm integrating area. And does it say find that area? Find that volume? It sure does, and I got 174.268 as the volume for this integral, or the volume of this region here. Okay, that was 5. Let's take a look at 6. 6 says, again with the calculator, R is the region in first and second quadrants bounded by, and we've got this rational function. Horizontal asymptote y equals 0, y-intercept at 0, 20. There's our curve, and the horizontal line y equals 2. Y equals 2. And so this is the region we're talking about. There's a little more symmetry than I've given it credit for. And that should be our maximum there. Okay, so find the region R. I can certainly find this point of intersection and this point of intersection. I might even be tempted to do it algebraically. 2 equals 20 over 1 plus x squared. 1 plus x squared equals 10 because I divided both sides by 2. X squared is 9, and so x equals 3. And so I know that this is the ordered pair 3, 2, and this is negative 3, 2. But I could certainly find this on my calculator. What are we supposed to find? This area of this region here. And so I could go from negative 3 to 3 of 20 over 1 plus x squared, that's the top function, minus the bottom function, y equals 2 dx. So simply integrating top minus bottom will get me the area of that region. When I do that, you could also set this up as 2 times the integral from 0 to 3 of 20 over 1 plus x squared minus 2 dx. Because of symmetry. There really is y-axis symmetry here, even though I haven't drawn it. I got, when I did this problem, 4.5 as the volume. Okay, that's part A. Part B says find the volume when R is rotated around the x-axis. So we want to rotate this region around the x-axis, and I've got washers again. There's a little radius, and there's a big radius. It looks like my little radius is this height, which is 2. My big radius is this distance, which is determined by this top curve's y value. So this is y, and that's going to be 20 over 1 plus x squared. So I have a big R and a little r, and again, I can set this integral up as pi big R 21 plus x squared minus little r squared dx, and I can integrate from negative 3 to 3. If I were in a position where I was doing this by hand, I might go twice the volume of 0 to 3, because I would rather plug zeros into an antiderivative than plug negative 3's into an antiderivative. So, but many of you will prefer this, and since it's on a calculator, it doesn't really matter all that much. I end up with 130.062 here. 130.062 is my volume when we rotate about the x-axis. What about part C? Part C says R is the region for a solid. Cross-sections perpendicular to the x-axis are semicircles. Okay, so now we've got a bunch of semicircles where the perpendicular are semicircles. Okay, so I've got this region and I'm bounding it at 2 and I'm making a semicircle here. Well, I see that the diameter of that semicircle is top minus bottom. So the diameter is 20 over 1 plus x squared minus 2. But I need radius in order to find pi r squared, the area of a circle. Oh, we've got semicircles, so we only want half of that, from negative 3 to 3. So we need a radius, not a diameter, and therefore our radius is going to be half of 21 plus x squared minus 2. You could, of course, distribute this 1/2 and now have r equals 10 over 1 plus x squared minus 1 as the radius. And this is what we want to put in here. So we've got pi over 2 integral negative 3 to 3 of r, which is 10, 1 plus x squared minus 1 squared dx. Don't forget, pi radius squared. So many people leave that squared off. Watch out. Okay, what did I get when I did this one? I got 8.1. I feel like I'm missing a decimal place there. Let's take a look at number 6 in my notes. Yeah, I got 8 point, but did I read it right? Oh, 5, sorry. 5, there we go. 5 is a different answer than 8.1. I'm sorry, no, this is problem 6. 6. I should have 174.268 for this problem. Uh-oh. I fear my numeration has gotten out of sync. Well, I think what I might do at the end of this video is go through once again what the answers should be, but this problem number 6 on the worksheet corresponds with my notes for number 5. How awkward. Which means in number 6, the answer to B should be 1871.190. And the answer to A should be 37.962, which I believe were the answers I gave you to the last problem. How frustrating. Okay, let's take a look then at problem number, that was 6. We're looking at 7 now. Problem number 7. Problem number 7. Okay. 7 says we've got these two curves, and the two curves are y equals x squared and y equals 2x. And if we consider this region, y equals x squared, y equals 2x, they intersect at 1, 1. This problem is without calculator. Find the area of R. So for part A, We're integrating from 0 to 1, and we just want the area of this, so I'm going to do top minus bottom, and that's going to be x squared minus x to the third over 3 from 0 to 1, which is 1 squared minus 1 to the third over 3, or 2/3. I get an area of 2/3 here. Let's just confirm that. Let's see. So this said region in first quadrant, x squared and 2x. Okay, x squared is the bottom function, 2x is the top function. The antiderivative of 2x is x squared. The antiderivative of x squared is x to the third over 3. And where do they intersect? Let's check that. So x squared equals 2x. X squared minus 2x equals 0. X minus 2. This isn't 1, 1. It's 2, 4. So I'm integrating to 2. I'm integrating to 2. 2 squared is going to give me 4. And then 2, no, that's still 1. Is that still 1? Come on, let's do this right. I put in zeros, nothing happens. So I put in 2 minus 2 to the third over 3. So I get 4 minus 8/3, which is 12/3 minus 8/3, or 4/3. Okay, there's part A. Part B. Part B says the region is the base of a solid. Each cross-section perpendicular to the x-axis has an area of sine pi over 2x. Find the volume of the solid. Well, okay, so we know that this, no, that's perpendicular to the y-axis. We know that this area, and I don't know that it's a square, I don't know what shape it is, I just know there's some sort of cross-sections that are perpendicular to the x-axis, and those areas of those cross-sections are the sine of pi over 2x. The sine of pi over 2x. So if I think about integrating area, that's going to be integrating sine of pi over 2x. Now, where am I integrating this dx integral? From 0 to 2. 0 to 2. So, if u equals pi over 2x, then du 2 over pi du equals dx. And so this becomes sine u du with this constant out in front. Now, if we use some u-bounds, we were going from 0 to 2. If I plug in a 0, I get 0. If I plug in a 2, I'm going to pi. The antiderivative of sine is minus cosine, and I want to go from pi to minus cosine of 0. And all of this, of course, is being multiplied by 2 over pi. Okay, cosine of pi is -1 with a negative out in front, that's 1. Cosine of 0 is 1. Minus a minus is plus, so I get plus 1. So I've got 2 times 2 over pi, which is 4 over pi is the volume. Okay, so there's part B, and again, please remember we're integrating area to find volume. They gave me the cross-sectional area. I didn't need to do top minus bottom squared. That would assume that these cross-sections are squares. Instead, there's some sort of strange thing going on here, and I'm just integrating that area. Okay, part C for number 7. Part C for number 7 says another solid has the same base. This time the cross sections are perpendicular to the y-axis or squares. Okay, so we've got y equals x squared, y equals 2x, this is 2, 4, and this time we're building squares. So I need that side length, and that side length is right minus left. This distance is x for y equals 2x. So this x is y over 2. And this distance is x to the other curve. This is y equals x squared, and now I want x as square root of y. So my right function is square root of y, my left is y over 2, and that's going to be the side of this square. And we want to integrate side squared. We're integrating areas. Since our slices go this way now, we've got dy slices, and so we must be integrating from 0 to 4. We're integrating square root of y minus y over 2 squared dy, right? It's side squared we need. There's our side, don't forget to square it, go from 0 to 4. So when I FOIL here, I'm going to have y minus y root y plus y squared over 4. That's not the antiderivative. That's just FOILing. So this is y to the 3/2. And now I need an antiderivative. I get y squared over 2 minus y to the 5/2 with a 2/5 in front plus y to the 3rd over 12, and I'm going from 0 to 4. So I've got 4 squared is 16 divided by 2 is 8. Square root of 4 is 2. 2 to the 5th is 32. 32 times 2 is 64 over 5. And then I plug a 4 in and I get 64 over 12. And that's where I can stop. I don't actually have to go any further. In fact, I didn't even need to do this. Duh. Right? But do not evaluate an integral. You know, it's good to read the question. It's good to read the question. Okay, there's problem number 7. Let's take a look at problem number 8 now. Problem number 8 is another region for us to consider. This time we've got square root of x and x over 2. Y equals square root of x, y equals x over 2. And my picture, square root of x, x over 2, they intersect at 4, 2. I'm going to confirm that algebraically because I'm tired of making mistakes in this video. I square both sides, I get 4x equals x squared, 0 equals x squared minus 4x, x minus 4 equals 0, so x equals 0 and 4. Great, and I plug a 4 in there and divide by 2 and I get 2. So here's my region R in problem number 8. I'm asked to find the area. This is without calculator. So my integral for part A will be top square root of x minus x over 2 dx. And I'm going from 0 to 4. So I always find it easier on my brain if I rewrite those radicals. So the antiderivative of this will be 2/3 x to the 3/2. And if you're not that fast with that, you need to do more integration practice. You've got a big packet, get working on it. And then over here, the antiderivative of 1/2 x, well, I'm going to have x squared as the antiderivative, and bring down that 2. I don't see a 2 here, so we must be over 4, so that when that 2 comes down, we cancel and we're left with 2. We're going to integrate from 0 to 4, so I want to evaluate this antiderivative from 0 to 4. Square root of 4 is 2, 2 to the third is 8, 8 times 2 is 16 thirds. And then here we have 4 squared is 16 divided by 4, which is 4. So I've got 16 thirds minus 12 thirds, or 4 thirds. 4 thirds looks like my answer to problem number 8A. Let's take a look at B. What does B ask us to do? Cross sections perpendicular to the x-axis are squares. Find the volume of the solid. So this is what we're looking at. The side length of the square is top minus bottom, also known as square root of x minus x over 2. That's side length. But we need side length squared here. We need side length squared, and so we're going to have the integral from 0 to 4, square root of x minus x over 2 squared dx. I do want to make sure that I read the problem carefully, but part B says, yes, perpendicular to the x-axis are squares, find the volume. So I need to actually FOIL this out. I'm going to get x minus x root x plus x squared over 4. That's not the antiderivative, that's just FOILing from 0 to 4 dx. This I would be happier writing as x to the 3/2, and my antiderivative is x squared over 2 minus 2/5 x to the 5/2 plus x to the third over 12. And we're integrating from 0 to 4. 4 squared is 16 divided by 2 is 8. Square root of 4 is 2. 2 to the 5th is 32 times 2 is 64/5 plus 4 to the third. 4 to the third is 64 over 12. I can reduce this to 32 over 6. I can reduce it further to 16 over 3. I think I want to make a common denominator here to make my life a little easier. But wait a minute, I can stop here. Why don't I stop here? I believe I did tidy this up, and I got 8 over 15 if you want to check your answer. But this would be sufficient. I guess I want to put in the minus 0 for good measure. But that should get the answer point. There's part B for number 8. And for 8C, we're asked to write but do not evaluate an integral. Write an integral expression. Do not evaluate when r is rotated about the horizontal line y equals 2. So we're still taking this region, but we want to rotate around this line y equals 2. So we're going to have a little radius, which is 2 minus y. So little radius is 2 minus square root of x. The big radius, that's this distance, is 2 minus this y value, 2 minus x over 2. So, and we're getting washers, so don't forget the pi out in front. 2 minus x over 2 squared minus 2 minus root x squared dx. Big R squared minus little r squared times pi, and we're integrating from 0 to 4. And this should be sufficient for us to earn our points for part C. Okay, let's take a look at problem number 9. Problem number 9 says, oh, it's our last page. We've got this region in problem number 9. And that's the point 9, 6. And what do we know about this curve? This is 2 square root of x equals y. And this is the horizontal line, y equals 6. Okay. This is without a calculator. So find the area of R. Again, for part A, I do top minus bottom. 6 minus 2 root x dx from 0 to 9. The antiderivative of 6 is 6x. Again, I hate writing it like that, and I would much prefer it like that. Minus x to the 3/2, and we're going to have 4/3 here. If we bring down the 3/2, the 3/2 will cancel the 3's and a 2, leaving me a 2 there. And we're integrating from 0 to 9. So I've got 54 minus 9 square root of 9 is 3. 3 to the third is 27. 27 divided by 3 is 9. 9 times 4 is 36. And so I end up with 18 here. Of course, you could leave that answer, but I would be embarrassed, and so I'm writing 18. Though, I'd be more embarrassed if I did the subtraction without a calculator and got that number wrong, so maybe you want to leave it like that. Okay, part B says, write but do not evaluate an integral expression that gives the volume of the solid rotated around the line y equals 7. Okay, so y equals 7 is going to be up here. I'm going to have a little radius. I'm going to have a big radius. My little radius is 7 minus 6, this top minus this bottom. So little radius, 7 minus 6, or 1. My big radius is from here to here. So this is 7, this is y. I'm going to have 7 minus y, and the y value for this curve is 2 root x. So my integral then would look like pi, big R, 7 minus 2 root x, don't forget squared, minus little r, don't forget squared, dx from 0 to where do they intersect? At 9. There's part B, write but do not evaluate an integral. Yeah, that's it. Part C, they say cross sections taken perpendicular to the y-axis, so they look like this, where the height equals 3 times this base is x, so the height is 3x, and this is x. So I would have 3x squared here, but I'm integrating this way, so I need everything in terms of y's. Well, I know that x, 2 root x is equal to y, so root x is y over 2, and x would be y squared over 4. So this x is going to be replaced with y squared over 4. Don't forget we wanted 3x squared dy. Sorry, I've been writing a lot of dx's. And since we're integrating with y's, we're going from here to here. So we're going up to 6, 0 to 6. Does this say find that volume? Or does it merely say set this up? Write but do not evaluate an integral expression. So we can have this, or if you prefer, you can pull out the constant. 4 squared is 16. And so we would have 3 over 16 integral 0 to 6 of y to the 4th dy, because y squared squared is y to the 4th. All right, so that's problem 9. There's only 2 left, one with calculator 10 and one without calculator 11. Problem number 10, figure shown, first quadrant bounded by y equals 4 ln 3 minus x, and the line y equals 6. So this is the region we're talking about. Okay, and in part A, they want us to find the area of this region. So I'm just going to integrate top minus bottom. 6 minus 4 ln 3 minus x dx. And we're integrating from here to here. They give me this ordered pair as 2, 0. So I'm integrating from 0 to 2. When I did this with my calculator for problem number 10, I ended up with 6.817. For part B, it says find the volume when r is revolved around the horizontal line y equals 8. So now I'm looking at Earth here, and horizontal line y equals 8. So this is my region. There's my little r. There's my big R. My little r is 8 minus 6, or 2. My big R is 8 minus y. And the y value to this curve is called 4 ln 3 minus x. So I've got a little r and a big R. Don't forget your pi. We're integrating from 0 to 2 because this is a dx integral. 8 minus 4 ln 3 minus x squared minus 2 squared dx would be my integral. And when I evaluated this, I got 168.180 units cubed for my volume for 10b. Yes, 10b. 10c asks us to consider cross-section to the x-axis are squares. Okay, so same region, but this time we've got squares here. And those squares, yeah, I'm just gonna try again. Those squares have a side length, and that side length is top minus bottom, which means 6 minus 4 ln 3 minus x. That's the side length, top minus bottom. But remember, we're looking for side squared. We're integrating area, so that's going to be side squared, which is going to be the integral from 0 to 2 of 6 minus 4 ln 3 minus x, and this is our side, so we want that squared. It says right, but oh, we've written it, and now we need to find the value using our calculator for this integral. And when I did, I got 26.267 units cubed for the volume. Okay, let's take a look at the last problem, problem number 10, and then I want to go back and I want to check the answers to the first few problems and make sure they line up. I think just 5 and 6 were flipped. but I do want to make sure the ones before 5 were good. Okay, problem number 11 says we've got a region bounded by f of x equals 8x to the third, and g of x equals the sine of pi x. So they give us this picture. They've got this. They've got this. We know this is g, and we know this is f, because this is that cubic function, and this is part of our sine curve here. This is without a calculator, so we're expected to figure that out. Part A, write the equation of the line tangent to the graph of f at x equals 1/2. So Riley always tells me I need an ordered pair, and I know what the x value is. To find the y value, I have to plug that in there. So I've got 8 times 1/2 to the third. Well, 1/2 to the third is 1/8. 8 times 1/8 is 1. So my ordered pair is 1/2, 1. But I also need a slope at that point. So I need f prime at 1/2. Well, I know f prime of x will be 24x squared. And so f prime of 1/2 will be 24 1/2 squared, or 24 times 1/4, or 6. 1/2 squared is not 1, it's 1/2 times 1/2, which is 1/4. So I've got a slope, I've got a point, I can write y minus 1 equals 6x minus 1/2 is probably what I would write and stop just there. Or you can, of course, tidy this up and get y equals 6x minus 3 plus 1 is minus 2. Okay, there's part A for number 11. Part B says find the area of region R. Again, this is without calculator. So again, I'm integrating I'm integrating top minus bottom. Top minus bottom. And so that's going to be in this problem sine of pi x minus 8x to the third, and we're integrating from 0 to, they tell me that this ordered pair is 1/2, 1. Okay, so the antiderivative of sine would be negative cosine pi x over pi minus 2x to the fourth from 0 to 1/2. So I plug in a 1/2, I get pi over 2, cosine of pi over 2 is 0, so I have a 0, and I plug in a 1/2. 1/2 to the fourth is 1/16, so I have minus 2 over 16, minus, I plug in a 0, cosine of 0 is 1, so I get minus 1 over pi, and I put in a 0 here, and I get 0. So it looks like I get 1 over pi minus 1/8. 1 over pi minus 1/8 units cubed? No, units squared, because it's an area. Okay, ooh, tricky. I have to think. All right, and then finally part C. Let's take a look at part C. It says write but do not evaluate an integral expression when r is rotated around the line y equals 1. Okay, so we're taking this region that we've drawn, and we're rotating around the line y equals 1. There's my inner radius. There's my outer radius. My inner radius, if this distance is 1, and this distance is y, then this is, little r, is 1 minus y. And the y value for this curve was our sine function. So that's 1 minus sine pi x. You could, of course, also write 1 minus g. My big radius, that's this distance. If this distance is 1 and this distance is y, then the big radius is also 1 minus y, but the y for this curve. So I've got 1 minus 8x to the third. I, of course, could write 1 minus f. Now, I'm supposed to set up but not evaluate an integral. So pi big R squared, 1 minus 8x to the third squared, minus little r squared, 1 minus sine pi x squared dx. And we're going from here to here, so we're going 0 to 1/2. And that looks great. There's my integral. Again, you really could set this up as, but it would just freak me out way too much. But I know some of you are out there thinking, can I do that? And yes, you could get away with that because f and g were defined for us by the College Board. Okay, let's take a quick look at those earlier questions just to make sure that my answers were spot on. So I believe what I noticed was that the answers I gave to problems 5 and 6 were switched. The answer to 5a should be 4.5. The answer to 5b should be 130.062. And the answer to 5c should be 8.1. I think I'm going to take the time to say 5 was the integral 0 to 4 square root of x minus x over 3 dx, and that's what I got 4.5 for. In part B, I had 2 pi integral 0 to 9 of 4x times square root of x minus x over 3 dx, and this was 130.062. And for part C, I had the integral from 0 to 3 of 3y minus y squared dy for 8.1. Okay, so that was 5. Let me go back and check 4 before I stop the video to make sure that 4 was in fact 4. 4 ln of x, yes. 3 had the sine 2x, yes it did. And 1 and 2, 1 was that, and 2 was that. Yeah, so the others should be fine. I just had a mix up on the answers for problems 5 and 6. I think when I wrote up my key, I did them in the opposite order for some reason. So this should be sufficient. Then you should be all set. I hope you enjoyed this first of 2 packets regarding areas and volumes. And hopefully by the time you get to the second packet, you're feeling pro on it. Okay, take care.